right, guys, welcome to another Advanced Refrigeration podcast, continued E2 training. Today we're going to be going over the air handler application inside of the E2. Now I'm going to be doing this on offline programming because my controller is an RX and you can't add an air handler to an RX. You can only use it on a BX or a CX, so we're going to do it on offline programming, which would be the exact same. We just won't be able to view it live. So same thing, right click on E2, you're going to add application. First thing you can choose is an air handler. So on the air handler, you right click, edit application. Okay, so we got a ton of stuff to go through, so we'll go through this. So name, you can name it AHU1, whatever you want to name it. Your long name, you can put it in there. Strategy. Okay, you have normal, you have T-stat, which would be like a T-stat on or off, and then you have separate set points. So we're going to go over normal, control type. So auto, you could have a heat or cool. Auto is going to automatically switch. You're going to have two different set point ranges. Okay, controlled by space temperature, zone temperature, return. So if you're using zones, you're going to use it on zone temperature. If it's just one AHU, you're going to use space temperature. If you don't have a space temperature and you want to use return, or say like the space temperature goes bad, you could set it up to run off the return sensor. So we're going to set it up for a space temperature. Temp combined output. So min, max, average. So we only have one. You could have up to 6 space temp sensors in there, and you could set it for minimum, average. Obviously, you want it to be average. Heat output type. Okay, you have two options. You have staged and modulating. So stage would be on off. Stages if it's Y1, Y2, Y3. I'm sorry, W1, W2, W3. For like heat stages. Modulating would be an analog signal. Say if you had a BLEMO motor driving a gun type burner, or you had a BLEMO driving a hot water coil or something like that, or steam, that would be modulating. So we're going to go stage right now. Okay, reclaim heat stages. So that would be your reclaim from your rack. So you have 0 to 8. So auxiliary heat stages is going to be your actual heat on the rooftop. Okay. So cooling output type. So you have staged and modulating. So modulating would be if you had, say, a BLEMO for chilled water, you want to do modulating. So we're going to do staged right now, which would be like on off, like a rooftop unit. Okay, heat pump stages. Is this thing a heat pump? So you have 0 to 2. So you could have 2 stages of heat pump on here. Cooling stages. So you could have 0 to 6. Okay. Fan, you have all these options. You have 2-speed, variable speed, CT drive, which would be an Emerson CT drive, single speed, variable speed. So we're going to go with variable speed so I can show you how to do the VS setup. Okay. So dehumidify by humidity, dew point, humidistat, dew point calculation, disable, outside dew point. So we're going to go dew point. So econ damper type. So you have analog or digital. So if you have a floating economizer, you're going to choose analog. If you have an open or closed economizer, you're going to choose digital. So Oss Selection, you have start, stop. I usually choose none. Apparent temp disable, yada, yada, yada. Not really sure what that is. Never seen it used. So it's always disabled. Phase protective. You have a phase monitor, yes or no. If you don't, click no, because it will take out the input for the phase loss monitor. Because your phase loss monitor is set to the global right now. If you have a individual phase loss monitor in the unit and you're tying it into an input, just make sure you do that. Now we go over set points. So we have summer cool occupied. We have summer cool unoccupied. So meaning when the occupancy isn't, when the building's closed, it's going to be 80 degrees. We have summer heat occupied, which would be 65. Summer heat unoccupied, which would be 60. So that's the heat settings for the summer. You have winter cool occupied, winter cool unoccupied. Then you have winter heat occupied and winter heat unoccupied. Now, this is where you get set up to where it's going to maintain your stages and it's going to auto switch from heating to cooling. This is what you want, unless you're going to switch it every single time, which I think is stupid because why even have the DVC controls if you're going to switch it by hand when you could let the set point switch everything. Okay, minimum cooling supply temp. This is what's going to drive your cooling stages when it's calling for cooling. So minimum cool supply temp cooling. So 55 to 50 degrees. You want a 55 to 50 degree supply air temperature. It's going to stage up your cooling for this. Now, make sure that your supply air temperature sensor is in between the cooling coil and the reclaim coil, because if the reclaim's on, it's going to stage all the cooling stages on. See this all the time, it gets messed up. Okay, so go to our inputs. You got your occupancy. This should come from global data from when the building's occupied or unoccupied, or a time schedule when the building is unoccupied or occupied, or this zone is occupied or unoccupied. Okay, so space temp 1, that's your space temp. Space temp dew point, that's going to have to come from a calculation, whether it be anti-sweat controller will do it for you, or you're doing it in a flexible combiner. Okay, return temp, that's going to be your return temp on a rooftop unit or an air handler. Supply temp is going to be the same thing. It's going to be your supply temp on the rooftop air handler. Mixed air temperature is going to be your blower temperature. So that includes your economizer and your return temp to make your mixed air temp. You don't need mixed air temp, but it's good to have it. Enthalpy switch, if you have an enthalpy switch in the rooftop unit. Outdoor temp, you could either have it from the global, which you probably should be, or it could be on the rooftop itself. Outdoor humidity should be global to all of them. But if this is your rooftop that has it, this could be the rooftop and it could be, writing to the global. So outdoor dew point, same thing. You would have to make a application to figure out what the dew point would be. So bypass to occupied or unoccupied, you could have a switch that goes to global or a push button override that like occupies all the HVAC, just like the lighting. So bypass to occupied, bypass to unoccupied. Set point shift, same thing. It could be a digital switch that shifts the set points. Curtailment would be like energy usage. So the curtailment would shut down, to on demand. Phase loss, unless you have like a global phase loss monitor, I mean, you're not going to have that. Emergency override, a lot of times this gets tied into like fire shutdowns or like a main rooftop shutdown. Summer, winter in, this comes from the global data of when the summer and winter starts. This is very important that you have this set up in global data, because otherwise your set points won't shift right. For the summer and winter, so if you look at winter occupied cool is 70, summer occupied cool is 70 on this, but generally like winter occupied cool will be like 75 degrees. It depends on the customer's set points. Okay, so now we have outputs. So your analog damper. This would be for your analog damper for the economizer. This is going to be your analog output. Fan failed. You could make this is a output. You could write to fan status, heat cool mode. These are all loggable points. I would log. And you could tie into a sensor control for other things if you want to. Not something I use a whole lot, but I mean, there's a lot of stuff on here you could write to. So these are all like things you could assign to sensor controls if you're trying to get statuses or RPMs and stuff like that. Okay, heat cool setup. This is where it comes in. So you have your heat TR range. This is the way the heat is going to function. You have your heat on delay, your heat off delay. So I recommend you put like a minute or two between stages, so that way you're not banging on and off. Heat minimum time on, heat minimum time off, same thing. Heat set point reference. So this is the end or the center of the PID. So they have it set to end. Your heat I gain, heat D gain. Leave the D gain at 0. I and TR are going to be your throttling range for your heat. Generally, the heat TR range, I usually bump it up around 25. It seems to work a lot better. So same thing with the cool TR range. I bump it up around 25 to maintain. So it's not bouncing around. Free stat set point, so 32 degrees. If you have a free stat in there, whether it's a digital, so cooling proof enable, if you click that to yes, you could set up a cooling proof. Heating lockout enable, so you could lock out on outdoor air temp, you could lock out the heat. So if you don't want the heat running in the summertime, free stat set point, cool on delay. So free stat would be so you're not going to freeze a coil inside the AHU to lock it out on free stat. So if you look through here, we have the cool fail reset, cool proof fail. Proof fails aren't something that gets used a whole lot. Generally we're integrating to a rooftop unit that's already all set up, and we're just telling it to turn on and off. Unless we are like doing a seasons 4 where we're doing all the control. Then seasons 4 will actually have, depending on what they have, they may have proofs on there, and depending on the customer. So same thing between stages. You have cool on delay, cool off delay, cool set point reference, the end of the PID, not the center. Same thing, I gain, D gain, cool curtail stages. You can shut down different stages of cooling. Now, this is mostly for energy savings. Don't see it used a whole lot because, most stores, especially where we are, we're not getting hit as hard with energy as like other states. So, when you start cutting back cooling, you start affecting dehumidification, which starts affecting cases. So down here we have cool lockout enable. So this is one I do use. So I will lock the cooling out below say 40 degrees. So say 45 degrees, I will lock out the cooling. Because there's no reason to run cooling at 45 degrees when we could be running the economizer at that point if we do need cooling. That's where all our energy savings is coming in for the economizer. Economizers are something we use in grocery stores a lot, but they're more so used to maintain building pressure, not so much to maintain temperature. So, okay, heat cooling stages. So we're in here. If we scroll up, this is our outputs for our heating and cooling. So, okay, we got our heating stages. This is where you're going to assign your board points. So heat stage 1, heat stage 2, heat stage 3, all that. And then cooling stages, all these. Just kick me up. Okay, then you have your proofs in here. So if we go to this, this is where you put your cooling proofs. So say if you had proofs that the cooling's running, so like CTs or digital inputs, that's where you're going to put your proofs. So then VS heat occupied percentage 50, VS heat occupied percentage 250. So free stat 1, this would be your free stat input. So it's going to be a digital input. So you're going to put your digital input for your free stat. Generally, if it has a free stat in there, you could have a digital input for it. So that's where you're going to put your free stat. We use a lot of chilled water coils in Chicago, so we have a free stat on everything. Generally, the free stat's located by the economizer, so that air is bringing in from outside. If the economizer opens too much or something happens with a coil or a damper, we shut the unit down so we don't freeze the coils. We try to save the coils so we aren't splitting U-bends and everything else. So this is your output and input setup for your cooling and heating stages. So if we go down to general fan, so fan or heat fan occupied mode. So you have auto, continuous, some are on, when are auto. So I always leave it continuous. Heat fan on occupied mode, continuous. If you want it to shut off, you put it to auto. If you want to run it summer on, winter auto, it'll shut off when it's not calling for heat. We want constant air movement in a grocery store. So heat fan run on, heat fan start delay. So if you were doing an RTU and you wanted to do the heating and you didn't want to kick that fan on and blow a bunch of cold air into the space, say it's like a small office and it's a small rooftop unit, you may do like a 15-second delay. Let the heat kick on for 15 seconds and warm up the heat exchanger and then kick the heat on. Okay, so cooling fan, continuous for occupied, unoccupied. Cooling run on and start delay. I don't ever mess with that. I mean, you just want the fan on during cooling. You don't want to have any free stats. Fan proof enable. So if you click this guy, yes. So it's going to give you a fan proof. Whether you have an amped LCT that you convert to a digital sensor control or it's a digital sensor control, you can have your fan proof in there. Okay. Now in here you have your fan bypass in and your fan reset. So if you are using a drive and it has a bypass for the drive, you could set that all up in here. Auto restart delay. So this is where your fan bypass output is going to be. Or I'm sorry, your input for your bypass. Say the bypass is on or your reset is on. So we go to advanced fan. Okay, you have your variable speed alarm out. You have your variable speed bypass right here. So if you click this is your input until it's in bypass. Okay, so now this is where we set our VS percentage. So we have VS occupied on percentage, VS unoccupied percentage. So this is how you can set your fan speed. So you'd say you wanted 100 in occupied and 50 unoccupied, meaning it's going to run at half speed. Probably can't run it at half speed. I mean, you got to see what the actual rooftop could do, but running it slower when you're not occupied will save energy, obviously, because we're running a fan slower, especially something with a 4 seasons with like a big 30 horsepower motor. Okay, you're running that motor at a 15 horsepower basically now, it's doing half the amount of work. So VS fail percentage, VS bypass percentage, all that. Now, minimum and maximum speed. Look at your RTU, get your numbers off the motor, and program that all in there. Variable speed increase and decrease rate. I don't ever use 2000. I usually go 500 and say like 600. Now, remember, this is not a compressor. This is not anything like that. We are just ramping up and down a fan. So it should be ramping off static pressure to maintain, or it's going to be a fixed ramp and ramp down. So say like the cooling is running, okay, I may be running 60% or I may be running 60 hertz, 100%. So say cooling's not running, okay, we'll step it back to 50%. We're just moving air around. So you could step the motor up and down that way. You don't need it to, respond fairly quickly like a compressor. So variable speed, your VS economizer percentage. So, okay, VS dehumidification slowdown. So you could set it to where the drive this is something I like about this. You could set it to where the drive reduces the fan speed to dehumidify on the call for dehumidification. So say you at cooling, you want to be at 60% or 60 hertz for 100%. Say you wanted to be at 80% and dehumidification. Now, this is going to slow the air down, which is going to reduce the actual coil temperature. So you're going to make your coil colder. Now, you have to watch this because if you get it too cold, you're going to start tripping on low pressure or icing the coils. So this is something you got to kind of play with. But this VS dehumidification slow percentage, it will slow the fan down. Say right now I've set to 80, it'll slow it down to 80%. Okay, this 80% will allow you to take and slow the fan down to dehumidify more. You'll lower your coil temperature. So say instead of running a 40-degree coil, you're now running a 34-degree coil. At 34 degrees, you're going to dehumidify way more than at 40 degrees. That coil's colder, so it's removing more moisture. So you're dehumidifying more. It's going to drive down your supply air temperature, but that's where reclaim comes in to rewarm it. Okay, VS economizer percentage. Again, you're going to have to play with this. You could write to the VS economizer input. Try to figure out where it is. It's in a different. It's in a different input. So, but you go right to this. Where's advanced? It's in the dehumid thing. I'm sorry, the econ. You could write to this and drive the economizer. Okay. VS inverter fails, so you can go all on or all off. Reset delay. VS ramp. So VS ramp. So you have differential or staged. So you can make it so it's differential or staged. Okay, so if you go differential, so you have all these different settings over here. VS heat differential, you're trying to maintain 9. VS heat TR 9, VS I gain, and then VS cool. So you have all these. So you can go staged. Staged is a lot easier. You have less PIDs to mess with. Then we go to dehumidification. Okay, so cooling dehumidification stages. So you have up to 6. So okay, so dehumidification out. So this would be if you have, it depends on what you're running for dehumidification. If it's an RT with reheat, yes. If it's a DH wheel, that's where you're going to tie it in. If it is reheat, you have to make a sensor control. So say reheat is your first stage of heating. So say rack 1 is your first stage of heating. Rack 2 is your second stage of heating. Rack 3 is your third stage of heating. So what you actually have to do is you can have up to 8 auxiliary heat demids. So this is, you could do multiple things with this, depending on how you do this. So say if I have reheat from a rooftop, okay, auxiliary heat dehumid, that is where I'll tie my heat dehumidification into. Okay, if I have it coming from a rack and it's also my stages of heat, what I will do is make a digital combiner, okay, and I will make a call for heat for stage 1 or stage 2, whatever it is, and a call for dehumidification. And I will make a digital sensor control, and I will use that, and I will control the output with that. So, with that being said, I will use that to control my dehumidification. So that way I could have one output to control dehumidification with multiple inputs. So whether it's calling for heat or dehumidification, it'll still bring the reclaim of the rack on. Now, you could use the global data to call for the reclaim. You could use that, say, a sensor control set up in the BX or whatever E2 you're using to control that air handler application and that digital sensor control, but your call for dehumidification for the reheat could come off global data. Now, that is the easiest way to do it. So now you have a dehumid occupied and you have a dehumid unoccupied. I have never used this, or sorry, never mind. This is a pointer or a fixed value. So say you wanted it at dehumid occupied 50, dehumid unoccupied 60. I don't know why you would want the same. I mean, keeping the humidity down as low as you can get it is just beneficial in general. So no dehumidification reclaim. We obviously don't want that because we have reclaim dehumidification. So say we have 2 racks doing reclaim dehumidification, and then auxiliary heat dehumidification would be, I'm sorry, I said that wrong. Auxiliary heat dehumidification would be heat stages. Okay, dehumid TR 9, minimum supply dehumid 55, minimum supply TR be 50. So it's going to try to maintain your supply air temperature. And then down here would be your dehumidification active. So your minimum space minimum space dehumid would say 50. So you're trying to maintain a 50-degree dew point on the dehumid. So if we go over to here, so we have our dehumid, occupied delta 2. Oh, shoot. Okay, so cooling dehumidification stages. If we have 2 dehumidification device present, yes. So that would be to run a DH wheel or something like that. Reclaim heat dehumidification would be rack reheat, or it will be rooftop reheat. So if the rooftop has a 3-way valve for that, you're using that. Auxiliary heat dehumidification would be like electric heat or gas heat in the unit. And then we have our set points here. So we're going to econ. Okay, econ delta be 2 degrees, econ unoccupied delta 2 degrees, occupied minimum damper. So this would set your minimum damper position. And then unoccupied minimum damper, whether you want it to be closed or open. So cooling mixed temp, 55 degrees is pretty standard. Cooling unoccupied mixed temp, 55. Cooling, I haven't really messed with the TR range on this. Summary, so you have calculated, so it's going to calculate the dew point. Max OA humidity, so you could change this to where it shuts the economizer if the humidity gets too high. Econ lock temp, so generally if it gets like, so you have 32 to 100, you could lock it. Enthalpy set point, so you could set your enthalpy set point in here. So if you look at a pressure or a temperature enthalpy chart, you could set your RTU to run off of that, which is going to be your most effective way to economize. So you're going to set your minimum damper positions off these and your maximum damper positions off these. Now you could write to the damper positions, I believe. So if we look here, you could write to the damper positions. I use this to like maintain building pressure. I will write to the damper positions and I will drive the damper open and close that way. So that way I can control the damper positions, and I use that to control building pressure on like a big AHU. So I'm controlling building pressure to keep a positive in the building all the time, because people don't realize, yeah, you're bringing in outside air, but if you can control the outside air coming in through our RTU, yeah, you're using a little bit more energy, but like you can control that that humidity and the temperature better than you can control it coming in through every door in the building. Like the front doors of the grocery store, when it's constantly opening and all that warm air and humidity or cold air is coming into the building, you can't control that. You have zero control over it. So it ends up affecting cases and rooftops and people. I mean, that air coming in there is just detrimental. But if you can control it coming in through a rooftop and you're running the cooling more or the heating more, but you're conditioning that air, you're going to be way better off, and it's going to be cheaper in the long run to control that. So that's where this comes in handy, and you can completely customize this rooftop unit to run with some programming. So power, so kW load, you can put in what the kW load is a rooftop unit. I've never done this. Primary demand bump, secondary demand bump, primary shed, load shed. I don't do any load shedding stuff. I mean, this is starting to become more and more apparent with like stuff Axiom's doing, where they're like shedding load on buildings with the RTUs. Obviously, you really don't want to shed load with racks that much. Because we're caring about product temp. But at 3 p.m., if we could shed some load and keep that peak demand charges down with rooftop units, yeah, I mean, let's do it with rooftop units. I mean, if you shut the rooftop units off for an hour, I mean, to save some energy, you could sacrifice not having to kill some refrigeration. So, not something we use a whole lot. I mean, that's more of an end user thing. So, emergency heat stages, emergency cool stages. So you could have emergency fan enable, whether it's yes or no. Emergency damper position, 10%. So, I mean, I usually make that 0. So if it does shut down, I'm not going to freeze a coil or something. Emergency variable speed fan percentage, usually put that at 60 or 100%. So if it does go into emergency, it leaves the fan running. So alarms, set point alarm delay, an hour. So control alarm enable, yes. So it'll give you all your temps for your zones. Humidity alarm enable. You could choose yes. High humidity set point is 158. It's ridiculous when it, so I'll say like 60%. And then same things for unoccupied and deoccupied. So I would rather have an alarm for the humidity being high than to get to a store and realize all the cases are iced up. I don't know about you. So set point reset enable. So if you include yes, so you could have a set point reset. So like you could change your cooling and heating set points. So say it gets to a certain temperature outside and you want to start kicking back. So outside air temp sensor. So say it's like 45 degrees outside and you don't need to maintain the store at 65 degrees. You could raise your set point 2 degrees or lower to set point 2 degrees. Same as cooling. You could, if outside air temp, you could raise or lower your temperature if you need be. And then system, you got restart loop. So that would restart the PID and then enable, which is your actual enable of the rooftop unit. So this is a general overview of the AHU application. Again, there's multiple different areas in this application to control inputs and outputs. So you just got to really pay attention, and it all depends on what your setup is. I mean, most of this air handler stuff is custom. If you're just doing a general rooftop unit, I mean, it's heat, cool. Now, I will tell you this. I will do some finagling basically on this. If I'm using not an ARTC board and I'm just using a general multiplex board and say I have no dehumidification, okay, say I have nothing on this roof, it's a Linux rooftop with no dehumidification, or like it has no reheat, it has nothing like that. Instead of my heating stages, okay, being 1, 2, 3, 4. Okay, so if I have 4 stages of heat, I'm not going to tie it to the multiplex board controlling this. Okay, say I have dehumidification and I have 2 stages of dehumidification. Where'd I go? Heat cool stages. So what I will do is I will actually take my dehumidification outputs and I will make a digital sensor control. And what I will do is I will take the heat cool setup. I'll make a digital combiner. I will make heat stage 1 the first input, and say dehumid stage 1 the second input. So if it calls for dehumidification, it will force the heat on. If it calls for heat, it'll force the heat on. So this is what I basically call, hillbilly dehumidification. We're using the gas heat at the same time as the air conditioning to dehumidify the building. Is it efficient? Absolutely not. But generally, gas heat is cheaper to dehumidify by than electricity, at least not by us. So what you could do is to run the gas heat to dry the building out to warm the supplier back up. And at the same time, you're warming that supplier back up, you're able to pull the humidity out of the building because you're keeping the load up on the building and you continue running the air conditioning. I will generally do this to a couple units. So say I have a building with just a bunch of package units, 15, 20 ton package units. Well, if they never run because the building's too cold, we're never going to dehumidify if they're never calling for cooling and the case is doing all the cooling. So what I will do is I will take and I will use the dehumidification outputs from this to run the heat on the rooftop package units. So, or say it's an air handler with gas heat unit heaters. So I'll force a unit heater or two on, and I'll use those to warm the building back up so I can dehumidify. The cost of that gas is going to be offset tremendously by the dew point getting lowered and the load reduction on the refrigeration. So I could use that dehumidification to drive that digital combiner. So that digital combiner is going to drive my dehumidification. So I will generally do it in stages. So I'll stage them, one, two, three, whatever I need to do. For some reason on offline programming, guys, like the dehumid outputs are not popping up. This will happen to you from time to time on offline programming. Not a big fan of doing it. So, but under the dehumid tab, so dehumid out, I will write that to that digital combiner. So that way I could force that dehumid on and I can warm up the building and dehumidify the building. That works great on buildings with no reclaim. I mean, not having reclaim from the rack to dehumidify really sucks, but in Chicago, 90% of our stores are not allowed to have reclaim just due to the constraints of the city. So gas reclaim is the best option we have. Electric strip heaters is not a great option. So gas reclaim works great for the application. So that's what I use for that. And I also use this fan and I drop the fan speed down as low as I can get it with keeping the coil temperature up in the rooftop units. So keeping the coil temperature on 34 to 35 degrees. You want to get that coil temperature down so you could pull more moisture out of the air. The only downside to using a multi-flex board and not a ARTC board or a multi-flex, it's an RCU board, which would be the air handler application type. You're kind of limited to this. You could write a lot of this, which would be your set points and zones, and then a lot of it gets transferred into that board. That board is a standalone board. This multi-flex board, or like we're running right now, if the rooftop application were to fail or the E2 were to fail, there's no standalone mode. An ARTC board and ARTU multi-flex board go standalone, meaning like they'll run without anything in the background. But we'll go over that next. We'll go over the ARTC boards and the RTU boards, and I'll show you guys how to set up the RTUs. This is more of like a general, like big air handler setup or like a custom setup you're doing. Generally like seasons 4 units and stuff like that. But thanks for watching, guys.